that we can all go through the robot escape. So let me first make sure that everyone gets the idea. So I'm this robot. I'm trapped in this maze, and I'm lazy. But fortunately, to compensate for that, I have these supernatural powers that I can clone myself. So instead of actually laboriously going out and finding an exit, I look straight ahead. I see that there is an opening. I clone myself and tell my clone, Fred, say, hey Fred, why don't you go on? Come back if you found something. And then I turn right. And I do the same thing with Fred 2 and Fred 3 and Fred 4. Right? One of them comes back and says, I know the exit. Now my job is to tell my master what the exit is. So how am I going to know what the exit is? I'm going to say, hey Fred, tell me, what's the exit? And then I just take that and put it into myself. And then if I'm asked what was the exit, then I can't answer that question. So have I moved? No. So oddly enough, I have not moved at all, right? How about Fred? Has Fred moved? No. What did Fred do? Fred said, I'm not going to go through that stupid maze. I'm going to clone myself and ask Jimmy and Jimmy 2 and Jimmy 3 and Jimmy 4 to explore the maze. So actually, every one of them just went one step and then asked someone else. So what I like about this example is that it shows the power of recursion. When it didn't tell you, when you realize right away that I didn't move. But you have the illusion that Freddie was busy exploring the whole thing, but what it means, it doesn't actually matter for me how Freddie found the answer. But yes, one level deeper, now we realize that Freddie is just as lazy as I was. And so it also shows why the recursion with the objects is kind of powerful, because you can visualize the 4 robots. So you've made these 4 different objects, each of which does the same thing. Now, why does the recursion have to stop? That's where the avoid list comes in. Because every time that you call the recursion, that it avoids one more position in the maze. Eventually, it must either have exhausted the entire maze because no positions are left, or it must have found an exit. So it's important, without the avoid list, if you take that out, then the thing just is an infinite recursion. It just never gets simpler. Then you just have all these robots, spawning new robots, and it doesn't come to an end. All right, so let's code it up real quick. So if the avoid list contains the current location, then that means I went on a bad location. What? Okay, that's because I typed. That was stupid. Yeah. See, it's always better to. So I goes from, I do it 4 times. I turn right. If I can move, then I'll clone myself. The clone needs to move so that it moves away from me. If the clone escapes, then I say, hey, give me the route. And I return semicolon. Yes. Oh, thank you. This is the one that I made a stupid typo. I hope I remember to fix that in the notes. And finally, it's possible that none of these are successful, in which case I should return false. That would be mean, that if there was no exit. And then when we run it. Okay, what did I do wrong? I should put it inside. No, if I put it here, that's no good. It is.
if return false is 1 up.
No, it isn't the for loop. I mean, here's the for loop, and here's the return. Then it would be inside the loop.
Oh,
That would be no good. Oh, no, it didn't. Thank you. Okay, yeah, here. Yeah, because I already punched out the hole in here. Oh, great, yeah. So here's what happens. In my solver, if you look over here in these spots here, I already punched out the hole. I did that last time. And so when I ran the original escape, then it ran around in circles because the right-hand rule doesn't work. But now, where it spawns the other robots, it successfully finds the exit. All right, that's that.